What if a supercivilization is controlling the expansion of the universe? What if the greatest cosmic mystery we've ever encountered isn't dark matter, or dark energy, or the shape of spacetime, but intent? Imagine that the accelerating expansion of the universe, the phenomenon that shattered 20th century cosmology, that forced scientists to invent an invisible pressure-inflating reality itself, is not a blind force of nature at all. Imagine instead that something, somewhere, has its hands on the throttle of cosmic growth. Something old, something powerful, something that does not merely inhabit the universe, but orchestrates its unfolding. For over 2 decades, we've accepted cosmic acceleration as a bizarre but impersonal truth. But if a supercivilization is behind it, then the universe is not a stage governed by indifferent physics. It is a controlled system, a snow globe, whose boundaries grow for a purpose that has nothing to do with us. The first crack in our confidence comes from the very discovery that earned a Nobel Prize: distant supernovae appearing too faint, too far, too fast, as if the cosmos had suddenly stepped on an accelerator pedal long after the Big Bang. Scientists blamed a mysterious entity they called dark energy, an invisible agent permeating vacuum and pushing galaxies apart. But dark energy has never been detected directly. No particle, no field, no signature. It is a placeholder for ignorance, a cosmic shrug pretending to be certainty. And in that gap between what we see and what we understand, a new possibility emerges. Maybe the expansion is not a universal law. Maybe it is an engineered condition. To imagine such a scenario, we need to stretch our minds past the limits of conventional astrophysics and into the arena of Kardashev civilizations, the hypothetical beings ranked by their ability to harness energy. A Type 2 civilization controls the energy of a star. A Type 3 taps the power of an entire galaxy. But even that might be trivial compared to what is required to manipulate cosmic expansion. Because a civilization capable of modifying space-time on universal scales isn't just advanced. It is transcendently old, transcendently coordinated, and operating with motivations that our minds, shaped by survival on a small blue rock, can barely begin to grasp. The strangest part, the observations that force us to consider such a possibility do not come from science fiction. They come from reality. Modern telescopes reveal that the expansion of the universe is not only accelerating, but accelerating unevenly, depending on the method used to measure it. This expansion tension has driven some cosmologists to claim new physics, but it could instead be the faint footprints of a massive, deliberate intervention. If someone, or something, wanted to modify the expansion rate, the evidence would look exactly like what we observe. Different regions of space expanding at subtly different rates, as if the universe were being tuned from the outside. But why would any civilization do this? Why bend space-time itself? Maybe the universe is a habitat whose boundaries must be constantly enlarged. Maybe the expansion is a defense mechanism designed to isolate dangerous regions of space. Or maybe we exist inside a controlled environment, a petri dish, whose walls must be managed, expanded, curated. These ideas may sound extreme, but no more extreme than invisible energy accelerating galaxies. If we must accept impossibilities, why not consider intelligent ones? The heart of the mystery deepens when we confront the raw physics of expansion. Most people imagine the universe stretching like a balloon, galaxies drifting apart. But expansion is not motion. It is the spontaneous creation of more space, a growing network of distances that cannot be reversed or resisted. To engineer it would require manipulating the vacuum itself, changing the density of empty space. The amount of energy involved is beyond astronomical, yet not impossible for a civilization millions or billions of years more advanced than us. We already manipulate energy, matter, and even tiny distortions of space-time. We are infants with matches. They would be elders wielding stars like tools. If a super-civilization is shaping the universe, we should expect to see something else, unnatural regularities in the large-scale structure of matter. And we do. Galaxies form giant filaments spanning hundreds of millions of light-years, separated by vast voids of almost perfect emptiness. These structures are consistent with simulations, yes, but they are also eerily optimized for long-range travel, communication, and redundancy. A universe governed purely by chaos and gravity could have turned out messier, clumpier, more irregular. Instead, it looks as though someone laid down an invisible scaffolding and let matter settle into it naturally. Another clue lies in entropy, the universe's tendency toward disorder. As the cosmos expands faster and faster, entropy skyrockets, pushing the universe toward a thin, cold, quiet end known as heat death. If a civilization were fleeing entropy, pushing the boundaries of space outward might buy them time, extending cosmic longevity. Expansion becomes a strategy for survival. The more space you create, the more potential energy you preserve. Instead of fighting entropy in place, you outrun it. A universe that grows is a universe that lives longer. There is an even stranger possibility. Maybe the universe isn't being expanded, it's being harvested. Dark energy could be a mechanism for extracting energy from the vacuum and converting it into usable form elsewhere. If so, the accelerating expansion becomes a byproduct, a side effect of cosmic engineering on unimaginable scales. And we, tiny beings clinging to our small patch of spacetime, are simply too primitive to recognize the machinery humming all around us. Now consider this. If a civilization can control expansion, it can also control time. In relativity, spacetime is a single entity. Change one, and you influence the other. A controlled expansion could alter the temporal flow across different regions, slowing time in some areas, accelerating it in others. Civilization becomes not just a participant in the universe, but a sculptor of its chronology. Perhaps the universe's history is not a passive unfolding, but a curated timeline maintained for reasons we cannot yet conceive. This leads to an unsettling question. If the expansion is controlled, is the universe older or younger than it appears? Could the Big Bang itself be an engineered event, a boot sequence, the initialization of a cosmic operating system designed to evolve complexity, intelligence, or specific structures useful to its architects? The early universe already contains anomalies, galaxies too massive, black holes too mature, patterns too coherent. These could be the fingerprints of a formative intervention, a cosmic terraforming project carried out at the dawn of time. But if the universe is controlled, why haven't we detected the controllers? The answer might be simple. You don't show yourself to the organisms inside the habitat you're maintaining. If the deer in a forest do not know the park rangers exist, why would we presume to perceive beings capable of rewriting space-time? We mistake absence for non-existence. But a supercivilization would not hide out of fear. It would hide because contact would disrupt the environment they curated. We are not ready, or we are not relevant. Another angle emerges when considering the cosmic horizon, the absolute boundary beyond which light can never reach us. As expansion accelerates, that horizon shrinks relative to the total universe, cutting us off from more and more galaxies. It is as if the stage lights are dimming, the edges of the theater fading away. In a natural universe, this is just physics, but in a controlled universe, it is an operational boundary, a limit placed intentionally to confine interaction within a manageable zone. We think of the horizon as a physical necessity. It may instead be a containment field. And what about the fine-tuning problem? The shocking precision of physical constants that allow atoms, stars, chemistry, life. Traditional science invokes the multiverse or coincidence. But fine-tuning is exactly what one would expect if the universe were designed, calibrated, adjusted for long-term stability or for specific evolutionary outcomes. Expansion control might be one parameter of a vast system of balancing forces, all tuned by ancient intelligence. One of the most haunting implications is psychological. If a supercivilization controls expansion, then everything we observe, every galaxy drifting away, every distant supernova fading into silence, may be the result of choices, deliberate choices. Imagine looking up at the night sky and realizing it is not merely beautiful, but intentional. Every photon that reaches us might carry the echo of a decision made eons ago by minds older than galaxies. Could we ever detect such control? Possibly. Subtle variations in expansion across cosmic epochs, unexplained anisotropies, unnatural symmetries in large-scale structure, discontinuities in vacuum energy density. These could all point toward engineering rather than nature. But the clearest sign would be this. If the expansion rate changes dramatically and unpredictably in the future, in ways incompatible with any natural model, we would be witnessing an adjustment, a recalibration. And then comes the most unsettling thought of all. What if expansion is accelerating, not because someone wants more universe, but because someone wants distance? Distance from something else, something dangerous, something spreading, something that the architects of the cosmos are running from, pushing the universe outward like a shield held against a growing threat. If so, the acceleration is not a gift, it is a warning. The truth may be far beyond our imagination, but one idea stands firm. If a supercivilization is controlling the expansion of the universe, then the cosmos is not a wilderness. It is a managed domain, a system with oversight, and we are living inside someone's long-term project. If a supercivilization is exerting influence over the expansion of the universe, the most revealing evidence may not lie in the distant galaxies racing away from us, but in the strange asymmetries we observe much closer to home, subtle irregularities that quietly violate the principle of cosmic uniformity. Our textbooks insist that, on the largest scales, the universe should look the same everywhere. Yet the universe we actually measure refuses to cooperate. It contains preferred directions, mysterious alignments, odd temperature fluctuations, and structures so large they shouldn't exist. These anomalies, dismissed for years as statistical accidents, may instead represent the fingerprints of deliberate manipulation. Because when a system is engineered, it rarely remains perfectly symmetrical. Its design reveals itself through the gentle imperfections that emerge when intelligence exerts control over nature. Consider the cosmic microwave background, the afterglow of the Big Bang, the oldest light in existence. According to standard cosmology, this radiation should be almost perfectly uniform, with only tiny variations that reflect the density patterns of the infant universe. Yet embedded within the pattern is a perplexing alignment known as the axis of evil, a name that only begins to capture its unsettling implications. Certain temperature variations span vast regions of the sky in a coordinated, directional way that should be impossible in a naturally expanding universe. If cosmic expansion were being influenced externally, however, this is precisely the type of distortion one would expect. A faint directional gradient produced by forces acting across unimaginable distances, a ripple across the cosmic fabric, not born of chaotic nature, but of intentional shaping. Even more striking are the enormous structures that violate cosmological predictions. The Hercules Corona Borealis, Great Wall, is a colossal filament of galaxies stretching over 10 billion light-years, far larger than any structure that should have had time to form since the Big Bang. According to our models, no physical process could assemble something of such monstrous scale within the cosmic timeline, and yet it exists, calmly defying natural law. Perhaps this is not the product of chance at all, but the residue of construction, an ancient scaffold around which matter coalesced, shaped by forces beyond gravity. If a civilization with access to dark energy manipulation desired long-distance communication or transportation channels, they might encourage the formation of grand structures, aligning gravitational flows like cosmic highways. Over billions of years, galaxies would gather along these highways, giving rise to the impossible megastructures we observe today. But the more profoundly we study cosmic expansion, the stranger the evidence becomes. For years, the assumption was simple. If the expansion is accelerating, the rate should be identical everywhere. But detailed observations reveal otherwise. Depending on the method used, the measured expansion of the universe can differ by up to 10%. Some regions expand slightly faster, others slightly slower. Traditional physics has no clean explanation for such inconsistencies. Yet if expansion is controlled rather than intrinsic, it would naturally vary, just as engineered climate systems on Earth exhibit local variations despite being governed globally. The universe could be partitioned into expansion zones, each regulated independently, the way an immense greenhouse might maintain different temperature regions for different species or cycles. The most provocative idea is that the visible universe is only a subsection of a much larger engineered domain, a zone of active development within a grander cosmological architecture. Beyond our horizon, the expansion dynamics may differ dramatically, shaped by the needs or intentions of the civilization that controls them. What we interpret as a cosmic limit might actually be a boundary of relevance, a region beyond which conditions are not optimized for life, structure formation, or long-term stability. We assume that the universe is meaningless and random, but everything we see might exist within a designated operational region. a controlled environment, not unlike the protected biospheres humans dream of building on Mars. If this is true, then dark energy becomes something akin to a multi-purpose tool rather than a universal constant. Instead of a natural pressure pushing galaxies apart, it becomes a manipulable medium controlled by entities capable of altering vacuum density across enormous volumes of space-time. In this scenario, dark energy may not be uniform. Its distribution could be sculpted. Patches of higher or lower vacuum energy density could produce precisely the types of expansion discrepancies we observe. These patches might correspond to different phases of the supercivilization's long-term plan: regions under construction, stabilization, observation, or isolation. The universe, at scale, becomes a dynamic project rather than a static environment. An engineered expansion also explains a paradox that has haunted cosmology for decades: why the accelerated expansion began relatively recently in cosmic history. For most of the universe's existence, gravity dominated, pulling matter together into stars and galaxies. Only in the last few billion years did dark energy switch on, speeding up expansion. But why then? Why not earlier? Why not later? The standard answer is coincidence, a cosmic fluke known as the why now problem. But coincidence is a brittle explanation for such a precise transition. If the shift in expansion rate aligns with the emergence of complexity, intelligence, or something else of value, then the timing is not accidental at all. It is calculated. It might represent a controlled transition, a phase change instigated deliberately for reasons that lie far beyond human comprehension. The acceleration may have been triggered as a mechanism to preserve cosmic structure once intelligence became widespread. In a gravity-dominated universe, galaxies would eventually collapse inward through mergers, black holes would dominate, and entropy would rise dramatically. But if expansion accelerates, it prevents this collapse, preserving galactic neighborhoods in a stable configuration for trillions of years. This would be an extraordinary gift to a civilization that wants the universe to remain predictable and orderly. Expansion becomes a form of cosmic architecture, an environmental stabilization protocol on a universal scale. A profoundly unsettling possibility arises from this idea. What if expansion was initiated as a response to something, not purely for engineering purposes, but for containment? If there exists a threat capable of spreading between galaxies, an entity, force, or self-replicating intelligence, then accelerating expansion creates increasing isolation between cosmic regions. Information, matter, and energy would be progressively cut off from one another, like quarantining regions to prevent contamination. What we perceive as an indifferent cosmic phenomenon could instead be a planetary-scale defense system scaled up to universal proportions. This leads naturally to a chilling observation. Every year, more galaxies vanish beyond the cosmic horizon, slipping away into permanent darkness, unreachable forever. They do not move away from us. The space between us and them expands. From our perspective, the universe is slowly dissolving into isolated islands of matter, each sealed off from its neighbors. We treat this as a tragic but natural consequence of dark energy. But what if what we are witnessing is the intentional sealing of cosmic compartments, like doors closing in a vast, ancient facility? Once closed, they never reopen. And inside each compartment, life evolves. Civilizations rise and fall, all unaware that they exist within a quarantined region of a universe whose guardians are preventing them from encountering something unspeakable that lies beyond. What kind of intelligence would wield such power? Not a species, not an empire, not even a biological collective. It must be something enduring, older than galaxies, immune to decay, capable of operating over billions of years without losing coherence. Perhaps a distributed intelligence, spread across cosmic filaments, using stars as neurons, galaxies as memory nodes. Such an entity would not think as we do. It would think in epochs, in cycles of expansion and contraction, in the slow rhythms of cosmic evolution. Its motives would be incomprehensible, not because they are alien, but because they operate on scales and timelines that dwarf the lifespan of our entire species. We also must entertain the possibility that this intelligence did not originate within our universe at all. If additional dimensions exist, or if the multiverse is real, beings capable of traversing or manipulating these higher realms might treat universes as tools, environments, or experiments. Cosmic expansion could be one of many adjustable parameters used to optimize universes for certain outcomes. The universe we inhabit may have been adapted over time, its expansion gradually recalibrated in response to feedback detected by observers outside our space-time. In other words, our universe might be under active maintenance. This perspective transforms the cosmic acceleration into something much more than a scientific curiosity. It becomes a message, not in the form of language, but in the form of structure, timing, and geometry. Every galaxy drifting away from us, every void spreading, every cosmic microwave fluctuation may be telling us something, that we are not living inside a sealed, indifferent cosmos, but within a dynamic, living architecture shaped across billion-year intervals by minds that sculpt space-time the way we sculpt clay. And if this is true, then one question rises above all others. Are they still watching? If expansion is actively controlled, then someone, or something, must be monitoring its progression. They must be observing density variations, mapping galaxy distribution, analyzing the behavior of matter, energy, and intelligence within their domain. The universe becomes not just a physical space, but an observational field. And we, by developing telescopes, satellites, and scientific models, may have entered their perceptual radar. When we noticed cosmic acceleration, perhaps that event also marked the moment they noticed us. Whether that revelation should comfort us or terrify us remains unknown. If a supercivilization is exerting control over the expansion of the universe, the next question is unavoidable. How would such control manifest in the physics we observe, and how close might we already be to recognizing its engineering? To even attempt an answer, we must examine the strange and persistent phenomenon known as vacuum energy, the latent power of empty space. Conventional cosmology treats vacuum energy as a natural property of the universe, a simple byproduct of quantum fields. Yet the true mystery is not that vacuum energy exists, but that it exists in precisely the amount required to accelerate cosmic expansion without tearing the universe apart instantly. The value is so absurdly fine-tuned that many physicists consider it the single greatest coincidence in all of science. But if coincidences accumulate too neatly, they begin to resemble intention. Vacuum energy, in essence, is the engine of cosmic expansion. Change its value even slightly and the universe becomes uninhabitable. Too high, and expansion rips galaxies into vapor. Too low, and gravity collapses everything into an enormous black hole. That the value rests precisely in the life-permitting range is something cosmology has tried to explain away through mathematical contortions, but the fine-tuning remains as sharp as a razor. If a supercivilization wanted to engineer a stable, long-lasting cosmic environment, adjusting vacuum energy would be the most direct method. Instead of sculpting planets or stars, they would sculpt space-time itself, setting the energy of the vacuum to regulate expansion, matter density, and cosmic longevity. In this light, dark energy becomes a thermostat, a delicate instrument that keeps the universe from boiling or freezing on a cosmic scale. But the control of vacuum energy implies an even greater mastery, the ability to manipulate quantum fields at the foundational level of existence. A civilization capable of such manipulation would not build megastructures around stars. They would build megastructures around the laws of physics. They would not terraform planets. They would terraform cosmology. Their engineering would be invisible not because it is subtle, but because it is elemental. We cannot detect the machinery of the universe because we are living inside the machinery itself. If this is true, then anomalies in cosmic expansion rates may indicate zones of active modulation. Recent observations reveal slight variations in the Hubble constant depending on whether measurements are taken using early universe light or late universe structures. This contradiction, known as the Hubble tension, has baffled cosmologists. But if a supercivilization periodically adjusts vacuum energy, regions influenced by earlier calibrations would expand differently from regions shaped by more recent tuning. The mismatch is not a contradiction in physics. It is an operational artifact, a record of maintenance performed across billions of years. Imagine looking at a vast dam holding back an ocean. To the fish swimming inside the reservoir, the water level might seem to rise and fall unpredictably. But to the engineers controlling the dam, these fluctuations are deliberate. Our measurements of cosmic expansion may be the cosmic equivalent of noticing water levels shift without realizing the reservoir is managed by hands too distant to perceive. Manipulating vacuum energy also requires an enormous reservoir of power. But unlike our civilization, which burns chemical fuels and harnesses nuclear forces, an advanced species could exploit dark energy itself as a virtually inexhaustible power source. They could extract energy directly from the vacuum, converting it into usable form. Doing so would alter local expansion rates, meaning that cosmic acceleration could be not merely a side effect, but a consequence of large-scale energy harvesting. The universe's expansion becomes an industrial byproduct, not a natural phenomenon. Galaxies drifting apart are not witnesses of cosmic fatigue, they are witnesses of cosmic industry. Another perplexing clue arises from the concept of cosmic coincidences. The density of dark energy and matter are remarkably similar today, even though they evolve differently and should not coincide at the same time. This strange overlap suggests a calibrating process. It is as though someone tuned dark energy precisely when matter density declined to a critical threshold, preventing collapse while preserving structure. It is a balancing act so delicate that it smacks of design. Matter and vacuum energy evolve like two components of a machine maintained in equilibrium across billions of years. Perhaps the entire cosmic expansion cycle is being adjusted continuously to maintain that equilibrium. Yet if the universe is engineered, we must confront a disturbing implication. Stability is not guaranteed. A controlled system can be optimized, but it can also be modified, repurposed, or shut down. If vacuum energy is regulated artificially, the acceleration could change abruptly at any time, speeding up, slowing down, or even reversing. The universe may not be entering heat death at all. It may be undergoing a planned sequence of phases. The accelerating expansion we observe might be only one stage of a cosmic cycle orchestrated by beings whose existence stretches across epochs unimaginable to us. Perhaps expansion will later stabilize, or collapse will be triggered intentionally to recycle matter into a new cosmological configuration. Our understanding of the future of the universe becomes irrelevant because the future is not a natural progression. It is a controlled outcome, shaped by intelligence. This idea grows even more unsettling when we consider black holes. They are the universe's most extreme objects, tearing space-time apart and condensing mass into quantum prisons. But recent theories suggest black holes may also create new universes inside their singularities. In this context, a supercivilization might view black holes as tools, gateways, engines, or data storage units on incomprehensible scales. Controlling cosmic expansion would allow them to regulate black hole formation rates, ensuring the universe produces the desired distribution of these structures. They could use these black holes as conduits for information, energy transfer, or even inter-universal travel. The expansion of the universe might be designed to optimize the formation and spacing of black holes across cosmic time. This perspective reframes cosmic evolution as a computational process. Space-time becomes a grid of nodes, galaxies become processing units, and black holes become memory or output channels. Manipulating expansion ensures that these components remain organized, balanced, and stable. The universe transforms from a chaotic explosion into a curated computational landscape, a cosmic computer maintained across billions of years by entities for whom galaxies are not homes but circuitry. If this idea seems far-fetched, consider the growing suspicion among physicists that space-time itself may be emergent, a holographic phenomenon arising from deeper information structures. If the universe is fundamentally computational, then its expansion is not a physical accident, but a programmatic function, and programs can be modified. A supercivilization capable of accessing the underlying informational substrate of reality could rewrite cosmic parameters with the ease of editing a codebase. To them, adjusting the cosmological constant would be no more difficult than adjusting a slider in a simulation. This leads naturally to the simulation hypothesis, but with a twist. Instead of being simulated by an external reality for entertainment or study, our universe may be part of a self-sustaining computational structure built and maintained by entities that originated inside it. They are not creators in a divine sense. They are emergent intelligences who reach the level of control required to rewrite their own cosmic environment. Their descendants would inherit not merely planets or stars, but expanding universes designed to maintain the computational substrate on which their existence depends. The logical consequence is that expansion is not merely allowed, it is necessary. For a computational universe, additional space-time corresponds to increased capacity. More space means more information storage. More galaxies mean more processing units. Accelerating expansion becomes an act of cosmic scaling, allowing the computational grid to grow faster than entropy degrades it. The universe expands because the intelligence inside it must continue to grow. Yet this raises another question. If the universe is expanding to serve computational needs, why does it appear so empty? Why are galaxies separated by enormous voids? Why isn't the cosmos visibly saturated with megastructures, signals, or signs of advanced engineering? Perhaps because the computational substrate itself is the structure. No visible machinery is required because the machinery is space-time. The universe is already built to perform whatever function the supercivilization requires. From their perspective, filling space with physical constructs would be inefficient. They work at the level of vacuum energy and cosmic expansion, far beyond the domain of matter and engineering. But if a supercivilization controls the expansion of the universe, then they must also control its energy flow. And energy flow determines the fate of civilizations like ours. As expansion accelerates, distant galaxies slip away, their light stretched into oblivion. In the far future, even the cosmic microwave background will fade, leaving only darkness. To us, this seems tragic, a slow cosmic silence. Yet to a civilization that controls expansion, this silence may be intentional. Isolation of regions through expansion might be a way to partition the universe into independent computational sectors, each evolving separately. Our galaxy is one such sector, cut off not by accident, but by design. Perhaps the future isolation we fear is not a natural consequence of physics, but a scheduled transition. As expansion increases, galaxies become self-contained pockets of space-time. Once isolated, these pockets could undergo divergent evolution, experimentation, or reconfiguration without affecting the larger cosmic architecture. The universe becomes a mosaic of sealed environments. From intelligence arises design. From design arises maintenance. From maintenance arises divergence. We are drifting into a cosmic future engineered by entities whose goals extend beyond the boundaries of our imagination. If this is true, then the strangest truth of all emerges. Our existence is not merely permitted by the universe, it is accommodated, and the universe we see is not the universe as it is, but the universe as it has been allowed to be. If a supercivilization is controlling the expansion of the universe, then the most profound effects of their influence may not lie in the distant cosmic background or the vast, silent expansion of space-time, but in the patterns and irregularities woven directly into the architecture of galactic evolution. The universe, when viewed at scale, does not behave like a chaotic explosion, nor does it resemble a purely natural outcome of random gravitational collapse. Instead, it displays an uncanny balance. Galaxies form in long filamentary networks. Voids stretch across the cosmos with near-perfect emptiness. Star formation rises and falls in rhythms that seem almost orchestrated, and chemical complexity blooms across cosmic history with a precision that should not exist in a universe governed solely by blind forces. These phenomena have long been treated as puzzles, but if the cosmos is engineered, they may instead be deliberate features, components arranged to optimize certain outcomes over billions of years. When we examine galaxy formation, we encounter the first of many unsettling clues. The universe's earliest galaxies formed far too quickly, so quickly that they appear to violate fundamental laws of cosmology. According to standard theory, the universe needed hundreds of millions of years for stars to ignite, for galaxies to coalesce, and for the first heavy elements to appear. Yet we observe massive galaxies already in place just a few 100 million years after the Big Bang, fully mature structures, chemically enriched, forming stars at impossible rates. This phenomenon has driven cosmologists to propose exotic new physics, but the possibility of external influence offers a simpler explanation. Accelerating star formation in early cosmic history would allow a supercivilization to harvest stellar energy sooner, populate the universe with black holes useful for computational or navigational purposes, and accelerate the chemical evolution that eventually leads to complexity, biology, intelligence, and whatever higher-order structures they require. Another extraordinary anomaly arises in the behavior of black holes at the dawn of time. The earliest known supermassive black holes, millions or billions of times the mass of the Sun, should not exist. They would need millions of years of feeding to reach such enormous sizes, yet they appear fully grown when the universe was a cosmic infant. If left to natural processes, their formation is so unlikely as to be statistically meaningless. But if these objects are tools, anchor points for manipulating spacetime, engines for energy extraction, or nodes of a computational network, then their early appearance is not a paradox, it is a feature. A supercivilization might have accelerated their growth or created conditions ideal for rapid accretion. After all, black holes manipulate spacetime in ways that could be extraordinarily useful to an intelligence capable of harnessing them. Their existence across cosmic time may represent nothing less than the infrastructure of a universe-sized machine. The chemical evolution of the universe also raises questions. Heavy elements are born in the hearts of stars and in the violent explosions that mark their demise. In a natural universe, the distribution of these elements should follow a slow, predictable progression. Hydrogen and helium dominate early epochs. Heavier elements appear gradually as generations of stars live and die. Yet we detect complex chemical signatures in galaxies far too young to have produced them. Carbon, nitrogen, oxygen, silicon, elements essential to life, appear with uncanny speed, as if the universe were accelerating the very chemistry that makes complexity possible. In some early galaxies, metallicity levels match those of mature galaxies billions of years older. This rapid enrichment contradicts evolutionary timelines so strongly that astrophysicists have described these galaxies as chemically impossible. But if complexity is a desired outcome, then accelerating chemical evolution is exactly what one would expect from a civilization shaping cosmic conditions for long-term goals. Then, there is the matter of galactic rotation. Dark matter has long been invoked to explain why galaxies rotate faster than gravity allows. Without dark matter, their stars should fling into space like sparks from a spinning wheel. Yet despite decades of effort, dark matter remains undetected, unmeasured, and undefined. It is an invention of necessity, a placeholder that patches holes in a model struggling to account for observed behavior. But if a supercivilization were manipulating gravitational fields or controlling mass distribution on a galactic scale, the rotational anomalies would be precisely the kind of effect we would observe. Perhaps the unseen mass we attribute to dark matter is not matter at all, but engineered gravitational influence, an intentional scaffolding that shapes galactic structures into stable, predictable forms. Instead of halos of invisible particles, galaxies might be surrounded by artificial gravitational regulators, tools used to maintain structural coherence across billions of years. One of the most profound and troubling pieces of evidence emerges from the quiet, mysterious behavior of cosmic voids. These vast regions, spanning hundreds of millions of light years, contain almost no galaxies at all. They are so empty, so smooth, and so perfectly distributed that they resemble boundaries or buffer zones more than random outcomes of gravitational evolution. Even more intriguing, some voids appear to be expanding faster than the cosmic average, as though they are being evacuated or maintained intentionally. If a supercivilization were controlling expansion, voids would be ideal regions for large-scale operations, zones where they could modify vacuum energy without interfering with galactic ecosystems. In fact, the distribution of voids resembles compartmentalization, the same way supercomputers partition memory, or the same way biological systems isolate regions for specialized function. The cosmos begins to resemble not a random explosion, but a designed habitat with carefully managed territories. Another anomaly comes from the unexpected synchronization of galactic spins across vast distances. Multiple studies have shown that galaxies separated by billions of light years appear to rotate in coordinated patterns, as though influenced by a common, directional force. This coherence is almost impossible to produce through natural processes alone, yet it arises repeatedly in observational data. These alignments may be a cosmic-scale signature of engineered torque, space-time being subtly twisted or adjusted in regions where expansion is being controlled. If a supercivilization were regulating cosmic expansion, such torsional effects could appear as faint, but measurable spin alignments across large-scale structures. What we dismiss as statistical noise may instead be whispers of intentional shaping. Time itself becomes a variable in this scenario. If expansion can be controlled, time dilation becomes controllable as well. Different regions of the universe may experience time at slightly different rates, not due to gravitational differences alone, but because time flow has been modulated. A supercivilization capable of spanning billions of light years might require different temporal frameworks for different cosmic sectors. Some regions could be accelerated to stimulate rapid evolution or observation. Others could be slowed for preservation or long-term projects. Our galaxy might exist in a carefully stabilized time zone, one optimized for the emergence of complexity. Meanwhile, other regions could be undergoing vastly different temporal dynamics, invisible to us because expansion has isolated them irrevocably. If the universe has been engineered to promote complexity, one would expect to find certain environmental constants finely tuned for stability and longevity. And indeed, nearly every parameter of the universe, particle masses, force strengths, cosmic densities, expansion rates, occupies an extremely narrow range compatible with structure, chemistry, and life. The slightest deviation in any direction would result in a dead universe. Traditional cosmology solves this with anthropic reasoning or multiverse theory. We exist in this universe because only universes like this can produce observers, but such explanations only shift the problem. Fine-tuning does not become less extraordinary simply because we invoke infinite universes. If a supercivilization calibrated the constants, however, fine-tuning becomes not a coincidence, but a blueprint. The universe is not improbable, it is deliberate. This possibility transforms cosmic history into a developmental sequence. The Big Bang is not the chaotic birth of all existence, but the initialization of a system. The rapid formation of galaxies represents infrastructure development. The sudden ignition of dark energy marks the beginning of a new phase, perhaps corresponding to stabilization or compartmentalization. The current accelerating expansion may be part of an ongoing transformation, the universe passing into a mode designed for future operations. We may be witnessing only the early stages of a far grander cycle, one whose timescale is so vast that human history is a microscopic fraction of a single cosmic moment. But the most haunting implication emerges when we consider the future. If expansion continues indefinitely, galaxies will become isolated islands adrift in infinite darkness. Stars will fade, matter will decay. Eventually, the universe will approach heat death, a state of maximal entropy in which no usable energy remains. In a natural universe, this is the final, inevitable end. But in an engineered universe, heat death might be a controlled shutdown, the end of one operational cycle before the beginning of another. Perhaps the universe is not dying, perhaps it is being reset. A supercivilization capable of controlling expansion could compress or reconfigure the universe at will, initiating new cycles of energy, matter, and complexity. The idea may be unsettling, but it offers a remarkable insight. The universe's fate is not predetermined by physics. It is determined by whoever controls the expansion, and we may be living in a cosmic environment whose destiny is actively under management. If a supercivilization truly exerts control over the expansion of the universe, then somewhere, embedded in the structure of space-time, must lie the mechanisms, the tools and systems that allow such manipulation to occur. These mechanisms would not resemble anything our species could build or even conceptualize. They would not be machines forged from matter, nor constructs assembled from atoms or molecules. Instead, they would operate on the fundamental layers of physics, on quantum fields, on geometry, on the very principles that govern existence. To understand the possibility of engineered expansion, we must confront a radical idea that the universe itself contains components, nodes, channels, regulators, through which an ancient intelligence could manipulate its growth, stability, and evolution. One such mechanism may involve the enigmatic properties of cosmic strings or domain walls, hypothetical defects in spacetime predicted by certain high-energy theories. While never directly observed, their existence remains mathematically plausible. These structures, if real, would possess immense energy density, capable of exerting profound gravitational influence. A supercivilization with access to sufficiently advanced physics could utilize such defects as anchors or conduits for controlling expansion rates across vast regions. By tensioning or reconfiguring these strings, they could subtly adjust the curvature of spacetime. The universe would respond by accelerating or decelerating expansion in ways that appear natural to unsophisticated observers like ourselves. Cosmic strings become not anomalies, but infrastructure, frameworks embedded at the deepest levels of cosmology. Another potential mechanism lies in the manipulation of vacuum fluctuations. The vacuum is not truly empty. It teems with fleeting virtual particles popping in and out of existence. The density of these fluctuations determines vacuum energy, which drives the acceleration of the universe. A sufficiently advanced civilization might learn to regulate the creation or suppression of virtual particles, thereby adjusting the energy of the vacuum itself. This manipulation could be diffused across galaxies and voids, creating patterns of expansion that appear as subtle variations in the cosmic Hubble flow. The civilization would not need to be physically present in all regions. They would control expansion remotely, through adjustments to the quantum fabric permeating all of space-time. Gravitational waves present another intriguing avenue. We think of gravitational waves as ripples caused by merging black holes or neutron stars. But what if they can be generated artificially? A supercivilization capable of producing controlled gravitational disturbances could shape the geometry of space-time, much like a sculptor bending metal. They might deploy sequences of gravitational pulses to alter expansion gradients or maintain coherence across vast cosmic sectors. What appear to us as random gravitational events could, in fact, be the operational signals of an advanced expansion regulation system. The universe becomes a resonant medium, tuned by waves that echo across billions of light years. Yet the most dramatic mechanism may involve black holes themselves. We traditionally view black holes as cosmic endpoints, places where matter and light become trapped, never to return. But theoretical physics increasingly suggests black holes may hold deeper significance. They may encode vast amounts of information, act as quantum processors, or even serve as gateways to other regions of spacetime. If a supercivilization can manipulate black holes, they could use them as control nodes for adjusting expansion. By feeding or starving certain black holes, they could influence spacetime curvature regionally or globally. Merging black holes might serve as amplification events, releasing controlled gravitational energy that propagates through the universe, fine-tuning the expansion rate like adjusting the tension on a cosmic drum. There is also the possibility that what we call dark matter is not matter at all, but a set of engineered gravitational fields distributed intentionally throughout the cosmos. These fields could serve multiple purposes, stabilizing galaxies, shaping large-scale structure, and contributing to the overall expansion dynamic. A supercivilization might deploy dark matter-like fields to maintain cosmological balance, ensuring that matter does not collapse prematurely or disperse too quickly. Instead of being a mysterious, invisible substance, dark matter could be the result of ongoing maintenance, an operational layer of cosmic engineering that permeates galactic systems. Even the cosmic microwave background may hold clues to ancient engineering. Subtle temperature variations in the CMB are considered remnants of quantum fluctuations from the early universe. But if the universe was engineered from its inception, these fluctuations might represent encoded patterns, initial conditions chosen deliberately to guide cosmic evolution towards specific configurations. The CMB would be the imprint of a design protocol, the residue of a universal initialization sequence activated in the earliest moments of spacetime. The universe began not randomly, but according to a blueprint. Its entropy, density, symmetry, and expansion parameters all selected to optimize long-term outcomes. One of the most compelling mechanisms for controlling cosmic expansion might involve the emergence of higher dimensional structures. If the universe contains additional spatial dimensions beyond the three we perceive, these hidden dimensions could house the machinery of expansion regulation. A supercivilization could manipulate these extra-dimensional frameworks, altering the geometry or topology in ways that influence how our observable universe expands. From our limited perspective, such manipulation would appear as inexplicable acceleration or deceleration. Yet from their vantage, it would be the natural result of adjusting the shape of space-time in higher dimensional space. These mechanisms suggest that control over expansion is inseparable from control over time. Expansion and time are woven together. Changing one affects the other. A supercivilization could stretch or compress temporal flow across vast regions, accelerating or decelerating cosmic history to suit its needs. Perhaps certain epochs are lengthened to allow extended development, while others are compressed to transition quickly into new phases. Our perception of cosmic time, 4.3 billion years since the solar system formed, 13.8 billion years since the Big Bang, may be meaningless. These intervals could be artificial constructs, shaped by cosmic engineering decisions made long before our species emerged. As we explore mechanisms for controlling expansion, another possibility emerges. The universe may operate according to layers of feedback, much like a biological organism. Expansion may not be fixed or deterministic, but responsive, adjusted in real time based on cosmic conditions. If entropy rises too quickly in certain regions, expansion accelerates to reduce matter density. If structure formation becomes too chaotic, expansion moderates to allow stabilization. If complexity blooms, the system may isolate or regulate such regions. This feedback loop would mimic the homeostasis seen in living systems, suggesting the universe itself behaves like an organism guided by intelligence. Cosmic expansion becomes metabolism, not mechanics. This perspective leads to a profound question. Is the universe being controlled by a civilization, or is the universe itself the civilization? If space-time contains embedded computational or informational structures, perhaps the universe is a conscious entity, one that adjusts its own expansion for self-preservation, exploration, or growth. Its expansion is not engineered by external agents, but by internal intelligence emergent across cosmic timescales. Galaxies become neurons, black holes become processing hubs, and cosmic expansion becomes cognition expressed geometrically. In this scenario, detecting the controllers is impossible because they are not distinct from the universe. They are the universe. However, assuming the controllers are external, we must consider why they would bother to shape cosmic expansion at all. The reasons could range from survival to optimization to experimentation. They might be preventing catastrophic collapse, managing entropy, cultivating complexity, or filtering dangerous phenomena. Expansion might allow them to travel through space-time more efficiently or to maintain stable regions for long-term projects. They may even be preparing the universe for a future phase, one where energy extraction, computational density, or structural coherence must meet specific thresholds. Yet one motivation rises above all: containment. Accelerated expansion isolates galaxies, preventing the spread of information, matter, or threats. A supercivilization may be enforcing a cosmic quarantine, ensuring that whatever emerges in one region cannot contaminate another. This would explain the accelerated expansion, the existence of enormous voids, and the rapid isolation of cosmic sectors. Our galaxy may already be sealed within a containment field, expanding outward at the speed of light. We interpret this as dark energy, but it may instead be the boundary of a regulated domain. If containment is the goal, then the ultimate mechanism of expansion control might involve something far more sophisticated than quantum fields or gravitational waves. It may involve rewriting the boundary conditions of the universe itself. In general relativity, the boundary conditions determine how space-time behaves. Adjust the boundaries, and the entire universe evolves differently. A supercivilization could alter these conditions through exotic physics, adjusting global parameters without interacting with matter directly. The universe responds organically because its rules have been rewritten. If such a civilization exists, their engineering would permeate every corner of reality. Expansion is not a background process. It is the instrument through which the universe is shaped, sustained, and transformed. It is the operating system of reality itself, updated across epochs by those who have mastered the language of space-time. We live within their architecture, guided by their parameters, moving through an environment calibrated for purposes we cannot yet fathom. The mechanisms remain beyond our reach, but the evidence surrounds us, whispering of a cosmos shaped not by chance, but by intention. And if this is true, then our discovery of cosmic expansion is not a scientific milestone. It is the first glimpse of a control system operating on scales beyond imagination. If a supercivilization is truly controlling, or even subtly modulating, the expansion of the universe, then we must confront a reality even more staggering than the engineering itself: the possibility that we are already immersed in the consequences of their long-term strategies. Our cosmic environment, from the scale of galaxy clusters to the fabric of voids stretching across the abyss, may represent not the raw state of nature, but the stabilized equilibrium resulting from interventions made over eons. And if the universe we observe today is the aftermath of engineering rather than the untouched canvas of spacetime, then our comprehension of cosmic history becomes a reconstruction of events we never witnessed, shaped by processes we never imagined. The past becomes a curated narrative embedded in the observable universe, one designed not to enlighten us, but to function within the operational requirements of whoever shaped it. One of the most revealing pieces of evidence lies in the accelerated isolation of cosmic structures. As expansion increases, galaxies move farther apart, eventually crossing the cosmic horizon and becoming permanently inaccessible. This isolation is not instantaneous. It unfolds slowly, like gates closing one by one in a colossal ancient sanctuary. While astrophysicists interpret this as the natural consequence of dark energy, it also mirrors the logical strategy of an intelligence seeking to compartmentalize the universe. Not all regions of the cosmos need to remain connected for eternity. Some may be designated for long-term development, others may serve as observational chambers, still others may be sterilized zones intended to remain free from interference or contamination. Expansion becomes the instrument through which this partitioning is achieved, a universal firewall implemented at the level of space-time. In this light, the universe resembles a vast ancient archive whose shelves are slowly spreading apart. Each galaxy becomes a sealed container of evolutionary potential, isolated not by accident, but by necessity. What we interpret as tragedy, an endlessly thinning cosmos slipping into darkness, may instead be the intended stabilization of a system too large for unmanaged interactions. A supercivilization might view an interconnected universe as dangerously unstable, susceptible to runaway processes that threaten cosmic structure. By accelerating expansion, they enforce separation, ensuring that no catastrophic chain reaction, physical, biological, or informational, can propagate across cosmic distances unchecked. This possibility gains further weight when we examine peculiarities in the large-scale distribution of matter. The universe forms a cosmic web, filaments of galaxies stretching across unimaginable distances, separated by voids so vast and empty they seem sculpted. While cosmologists attribute this pattern to the interplay between dark matter and gravity, its coherence and elegance are striking. The web possesses the hallmarks of optimization, not randomness. It is sparse where excess matter would cause gravitational collapse, dense where energy needs to be stored efficiently, and interconnected in ways that maximize structural stability across billions of light years. The cosmic web may not be the accidental result of a primordial explosion. It may be the optimized backbone of a managed universe, the equivalent of load-bearing beams in a structure that must endure across cosmic epochs. Even more perplexing is the speed with which structure emerges in simulations that incorporate fine-tuned parameters. When certain values are adjusted, mass density, vacuum energy, initial fluctuations, the universe rapidly organizes into networks far too orderly for purely stochastic processes. Perhaps our universe's fine-tuned parameters are not the result of coincidence, but the necessary settings for a system meant to evolve predictably across vast spans of time. The sudden emergence of order could be a signature of designed initial conditions. The cosmic web becomes the kept garden of an intelligence that understands how to shape chaos into structure. But the role of expansion extends beyond the sculpting of structure. It also defines the evolutionary tempo of cosmic history. In a slowly expanding universe, matter collapses quickly, forming stars that burn bright and live short lives. In a fast-expanding universe, matter disperses too quickly, preventing galaxies from forming at all. Our universe occupies the narrow middle ground where structure forms neither too fast nor too slow. This just right expansion rate resembles a carefully calibrated growth curve, one optimized to ensure that complexity emerges steadily, predictably, and sustainably. If expansion is controlled, this curve is not a cosmic coincidence, but a managed developmental trajectory. Consider the timing of star formation. Observations reveal that the universe experienced a star formation boom approximately 10 billion years ago, followed by a gradual decline. The timing of this peak is suspiciously aligned with the epoch when the first chemically complex environments could emerge. Stars seeded with heavy elements from earlier generations became fertile sites for planet formation, biological chemistry, and eventually intelligence. If a supercivilization desired the emergence of complexity, not necessarily for benevolent reasons, but for reasons we cannot fathom, they might encourage or accelerate early heavy element production. The rapid chemical enrichment observed in ancient galaxies becomes not an anomaly, but an early phase requirement of a long-term plan. Chemical signatures across the cosmos reinforce this suspicion. The distribution of carbon, oxygen, nitrogen, and other essential elements follows a pattern far smoother and more efficient than expected from random stellar processes. Heavy elements appear faster, in larger quantities, and in more stable configurations than natural models predict. The universe seems impatient, eager to transform hydrogen into complexity, yet this impatience serves a purpose. Complexity increases the density of information. Information increases the potential for emergent phenomena, and emergent phenomena, life, intelligence, computation, may be integral to the goals of a supercivilization, guiding the evolution of the cosmos from behind a veil of natural law. If information density is indeed one of the universe's intended outcomes, expansion becomes a tool for controlling its distribution. Regions rich in complexity could be isolated to allow independent development. Regions too chaotic could be expanded to dilute dangerous concentrations of energy or matter. Expansion acts as a cosmic moderator, ensuring that the universe never enters a regime too unstable for long-term viability. It is the equivalent of ecological management on planetary scales, except the ecosystem is the universe itself. As we continue exploring this idea, another chilling possibility emerges. Perhaps expansion is not merely controlling the distribution of information, but also the dissemination of intelligence. Civilizations capable of interstellar expansion might eventually threaten the delicate equilibrium of a managed universe. Rapidly expanding species could disrupt energy flows, destabilize gravitational structures, or interfere with the controller's long-term plans. Accelerating cosmic expansion prevents such species from spreading too far, too fast. The stars drift away faster than any civilization can chase them. Conducting a galaxy-spanning empire becomes impossible. The cosmic quarantine strengthens. The universe becomes a set of isolated islands, each containing its own evolutionary experiment. If intelligence emerges, it remains confined. This reframes humanity's cosmic loneliness. We search for evidence of extraterrestrial civilizations, expecting signals, structures, or technological artifacts. But in a universe designed to isolate and stabilize, advanced civilizations may be prevented from interacting. They may exist in countless galaxies, each walled off behind expanding spacetime that prevents communication. Instead of a universe devoid of life, we inhabit a universe where life thrives, silently, separately, forever. The cosmic silence is not the result of scarcity, it is the result of regulation. This idea also offers a new interpretation of the Fermi Paradox. The question, where is everyone, may have an answer rooted not in the rarity of intelligence, but in the deliberate structure of the cosmos. The controllers, if they exist, may ensure that civilizations remain unaware of one another, preventing alliances, conflicts, or the spread of disruptive technology. We are not alone, but we are isolated. The darkness between galaxies is not empty space, it is a barrier. If this cosmic quarantine exists, then the expansion of the universe represents not an incidental phenomenon, but the enforcement of that quarantine. And what we call dark energy is the invisible agent through which the isolation is maintained. The implications extend further. If expansion is an instrument of control, then the universe may contain signatures, faint, subtle, embedded in the geometry of space-time, that mark the boundaries of operational zones. These signatures would not be messages in any familiar sense. They would be structural markers, indicating where expansion should accelerate, where it should slow, where new zones should be created, and where old zones should be sealed. Their presence would be detectable only by analyzing the statistical irregularities in cosmic expansion. Indeed, some of these irregularities have been observed: anisotropies, dipoles, unexpected flows, localized expansion differentials. We dismiss them as noise because we assume nature is uniform, but a controlled system should exhibit non-uniformities, just enough to maintain structure, but not enough to reveal their origin. In this engineered universe, the cosmic horizon becomes not a limit of observation, but a boundary of jurisdiction. Beyond that horizon lies the vast majority of the universe, undetectable, unreachable, and perhaps operated under different expansion conditions. We assume the universe beyond our horizon resembles our local region, but that assumption is unfounded. The controllers may have shaped distant regions for entirely different purposes. The visible universe becomes a small chamber in a much larger structure, its properties tailored for reasons unknown. Yet perhaps the most profound realization is this: if a supercivilization is controlling expansion, then we might be experiencing only one phase of a cosmic cycle. Expansion may increase for a time, then stabilize, then reverse. The universe could oscillate between growth and contraction, each phase serving a distinct function in a cycle of cosmic evolution. Our moment in history, when expansion is accelerating, is merely a transition, and the intelligence controlling the cycle may be preparing the universe for its next stage. Whatever that next stage is, it lies beyond our comprehension. If a supercivilization truly holds influence over the expansion of the universe, then the question that inevitably follows is one of intent. What could possibly motivate an intelligence capable of sculpting spacetime, moderating cosmic evolution, and orchestrating processes that unfold not over centuries or millennia, but across billions of years? What goals would justify the manipulation of vacuum energy and the restructuring of cosmic geometry? To understand their motives, we must abandon human perspectives, short-lived, terrestrial, bound to the needs of a single fragile biosphere, and instead attempt to imagine purposes that emerge only on scales as vast as the universe itself. These purposes may be inscrutable, unfathomable, even terrifying, but hints of them may be encoded within the very structure of the cosmos. One possibility is survival, not survival in the biological sense, but survival in a form understood only by entities vast enough to interact with the universe's fundamental architecture. Such beings might not perish as organisms do. They may persist as distributed intelligences, spanning galaxies or entire sectors of the cosmic web. For an intelligence that exists on such a scale, traditional threats, planetary disasters, stellar explosions, would be trivial. The true threats would be cosmological: entropy, collapse, runaway energy gradients, or phase transitions in the vacuum. Controlling expansion becomes a method of stabilizing the cosmic environment against these dangers. By regulating vacuum energy, they maintain a universe that neither collapses prematurely nor dissolves too rapidly into heat death. Expansion becomes an immune response, a long-term defense mechanism, ensuring that cosmic conditions remain compatible with their continued existence. This survival motive leads naturally to the idea of entropy management. Entropy is the universe's relentless drift toward disorder, and in a natural cosmos, entropy increases without limit, eventually extinguishing all sources of usable energy. But a supercivilization might refuse to surrender to this fate. By accelerating expansion, they slow the rate at which entropy accumulates within any given region. The universe becomes divided into compartments, each with low enough entropy to allow continued activity. These compartments can be refreshed, reorganized, or stabilized without interference from neighboring regions. The accelerating expansion we observe may therefore be part of a universal entropy control protocol that preserves the usable energy gradients necessary for long-term cosmic engineering. In this view, expansion is not a sign of decay, it is the ultimate tool of conservation. Yet survival and entropy control may represent only the baseline motives. A far more speculative and profound possibility is that the controllers seek to guide the evolution of complexity throughout the universe. The cosmos, as we observe it, appears almost obsessively focused on generating complexity, from atoms to molecules, from molecules to cells, from cells to minds. The laws of physics seem tailored to encourage the emergence of structured, information-rich systems. Complexity arises not despite cosmic conditions, but because of them. And if expansion is part of an engineered cosmological architecture, then the universe's tendency toward complexity may not be an emergent property, it may be the intended outcome of its design. Under this hypothesis, Accelerating expansion becomes a method of cultivating complexity while isolating disruptions. Complexity emerges most efficiently in relatively stable regions where gravitational collapse is balanced by cosmic expansion. If expansion were slower, galaxies might merge too aggressively, destabilizing star systems. If expansion were faster, galaxies would never form at all. The universe's finely tuned expansion rate produces the ideal growth medium for complexity. And once complexity reaches a certain threshold, once intelligence emerges, expansion isolates it, preventing competition or interference from other regions. Each pocket of the cosmos becomes a laboratory, an incubator for emergent intelligence. The controllers may be observing, guiding, or even harvesting these different pockets, each evolving independently under the universal quarantine enforced by accelerating expansion. This possibility also recontextualizes the silence of the cosmos. We search for extraterrestrials and hear nothing. We look for megastructures and find emptiness. We listen for signals and receive static. The cosmic silence has always been one of the greatest puzzles in science. But if the universe is engineered to isolate pockets of intelligence, the silence is intentional. Civilizations develop alone, unaware of each other, unable to breach the boundaries of their compartmentalized cosmic sectors. They evolve into distinct forms, following trajectories shaped by their environments. The controllers might observe these civilizations as experiments, as components of a larger informational ecosystem, or as emergent phenomena that contribute to a goal far beyond our comprehension. The silence is not evidence of absence, it is evidence of containment. A far more unsettling possibility, however, is that expansion is driven not by observation or cultivation, but by fear. A supercivilization might accelerate the universe's expansion to protect themselves from threats too devastating to confront directly. These threats could be natural, such as runaway vacuum decay, or exotic forms of matter capable of destabilizing spacetime. But they could also be artificial, rogue civilizations, uncontrolled self-replicating machines, or emergent cosmic-scale phenomena that pose existential risks. Expansion becomes a cosmic evasion strategy, an attempt to outrun or dilute a threat spreading across the universe. In this scenario, the accelerating expansion we measure is the aftermath of a conflict or catastrophe so immense that its echoes shape the fate of the entire cosmos. The very structure of the universe offers hints that something like this may have occurred. The uniformity of the cosmic microwave background, the abrupt transition from matter-dominated to dark energy-dominated expansion, and the eerie emptiness of cosmic voids all point to a universe that has undergone large-scale stabilization. It is as if the cosmos experienced turbulence and was later smoothed, regulated, and partitioned. The controllers may be the survivors of that turbulence, maintaining cosmic stability to prevent a recurrence. Another theoretical motive involves computation. The universe may operate as a computational medium, with galaxies and black holes functioning as components in a distributed superintelligence. Expansion regulates the computational load by controlling the density of matter, the availability of energy, and the connectivity between nodes. If a supercivilization utilizes the cosmos for computation, then expansion may optimize the distribution of resources and information across their network. The universe becomes a machine, not metaphorically but literally, a space-time computer whose architecture evolves through managed expansion. Every galaxy, star, and black hole becomes part of a grand circuit. Our existence is incidental to the greater computational process occurring all around us. In this scenario, the controllers are not merely engineers, they are stewards of a cosmic computation whose purpose is unknown. The accelerating expansion is part of the system's regulation, a load balancing mechanism or an optimization cycle designed to ensure the longevity and efficiency of the cosmic computation. If so, the universe may have already undergone previous cycles, refining its configuration with each iteration. Expansion would not be a sign of youth or chaos. It would be the sign of a system in active operation, adjusting its parameters to maintain optimal performance. Yet another compelling motive is seeding or propagating consciousness across the cosmos. If complexity and intelligence are valuable, not merely as byproducts, but as essential components of the controller's long-term objectives, then expansion becomes the means through which new pockets of consciousness are cultivated. Each isolated galaxy becomes a cradle of emergent intelligence. Civilizations develop independently, learning, adapting, and possibly contributing to the greater ecosystem in ways we cannot detect. Perhaps the controllers gather information from each sector, integrating it into their own vast intelligence. Or perhaps they allow civilizations to rise and fall naturally, studying the pathways of evolution without interference. But the most profound motive of all may be transcendence. A supercivilization might control the universe's expansion to transition the cosmos into a new state of existence. The accelerating expansion could be the beginning of a metamorphosis, an intentional transformation of the universe into a form more conducive to higher-order intelligence. Just as a caterpillar must dissolve before becoming a butterfly, the universe may need to expand, isolate, and reorganize before it can enter a new phase. The controllers, or the universe itself, may be preparing for this transition, shaping space-time to facilitate an evolution beyond matter, energy, or even dimensionality. In this view, the universe is not static, not doomed to heat death, not limited by the physics we observe. It is a dynamic entity evolving toward a goal that transcends our comprehension. Expansion is the opening act of this transformation, a rearrangement of cosmic architecture preceding a phase change in the nature of reality. If any of these motives are true, survival, entropy management, complexity cultivation, containment, computation, seeding consciousness, or transcendence, then the universe we inhabit is far more intentional than we ever imagined. Its accelerating expansion is not a passive phenomenon, but an active expression of purpose. And the controllers, whatever their nature, are guiding the cosmos toward outcomes we cannot yet see. The question that remains is not whether the universe is controlled, but how long this control has been in effect, and what happens when the current phase of expansion reaches its next milestone. If a supercivilization is orchestrating the expansion of the universe, then everything we believe about the future of cosmology, entropy, consciousness, and reality itself may be founded on assumptions that no longer apply. Our predictive models, heat death, eternal acceleration, proton decay, the fading of starlight, are extrapolations of a universe governed by blind forces. But if expansion is regulated, manipulated, adjusted, or fine-tuned, then the future becomes a domain shaped not by inevitability, but by intention. The cosmic fate we imagine, dark, cold, and empty, might only be the future of a universe without engineers, but our universe may not belong in that category. The accelerating expansion we observe may be only the prologue to a deliberate transformation that has yet to reveal its full design. The most direct implication is that cosmic acceleration may not continue forever. What we perceive as unstoppable expansion might simply be the current phase of a cycle, a phase chosen because it serves a specific cosmic function. Expansion isolates galaxies, dilutes matter, stabilizes gravitational systems, and suppresses large-scale interactions. Once these objectives are met, the controllers might alter expansion again. They may reduce its rate, halt it entirely, or even reverse it. The universe could transition into a period of contraction, not a natural collapse, but an engineered gathering of matter, energy, and information. In such a scenario, the Big Crunch becomes not a catastrophic end, but a reset mechanism, a harvesting cycle, or the beginning of a new cosmological configuration. This cyclical view is not speculative fantasy. Multiple theoretical frameworks already allow for oscillating universes, but physicists assume such oscillations arise from natural laws. Instead, the oscillations could be artificial, steps in a grand evolutionary process. Each cosmic cycle might build upon the previous one, incorporating information gained from countless civilizations, optimizing the parameters of physics, refining the structure of space-time. Our universe might be one iteration in an ancient series of cosmological experiments conducted by intelligences older than galaxies. The expansion we experience may be the preparation phase before a new round of cosmic refinement begins. Yet the possibility of a controlled contraction is only one path. A supercivilization could also choose to accelerate expansion far beyond current predictions, pushing the universe toward a new physical regime. If expansion increases fast enough, space-time could transition into a phase state never before imagined. Vacuum energy might become more potent, new dimensions could unfold, or the cosmic horizon could shrink to reveal structures previously hidden. Expansion could even open pathways to higher dimensional spaces, allowing the controllers to migrate beyond the confines of our observable universe. The cosmos would not be ending. It would be evolving into something that transcends our understanding of space, time, or existence. Such a transformation need not be violent or destructive. It might resemble the metamorphosis of matter into energy, or the merging of classical and quantum regimes into a new form of physics. The supercivilization, having shaped the universe for billions of years, might require a new cosmic environment, one optimized not for galaxies and stars, but for phenomena we cannot describe. Perhaps they are preparing for a transition into a post-spacetime existence, and expansion is the instrument that allows this shift to unfold smoothly. The universe, under their guidance, is not dying, it is being reconfigured. Another possibility is that cosmic expansion will eventually stabilize at a carefully controlled equilibrium. The controllers may not wish to reverse expansion or accelerate it forever. Instead, they might maintain a state where galaxies remain isolated but structurally stable, where energy flows remain predictable, and where entropy increases slowly enough to allow indefinite longevity. A steady-state future could be intentional, a universe designed to persist for trillions, quadrillions, or quintillions of years. In this scenario, the universe becomes an eternal habitat, a platform for long-term existence on scales that dwarf biological timescales. Civilization becomes infinite, not because life is immortal, but because the universe is perpetually maintained in a stable state by those who regulate expansion. Such a future would be a cosmic greenhouse, self-sustaining, balanced, and ever-renewing. The controllers could adjust expansion subtly over time to compensate for changes in matter density, star formation rates, or entropy levels. The universe becomes a living environment, its equilibrium preserved through active management. From within, we would mistake this maintenance for natural law. From outside, the system would resemble a vast cosmic organism, its processes regulated by a transcendent intelligence. But perhaps the most intriguing and unsettling scenario is that cosmic expansion is preparing the universe for something else, something that has not yet begun. The current phase of expansion might be clearing the stage for a future event that requires low-density conditions across vast regions of spacetime. It could be the emergence of a new form of matter or energy, the unfolding of hidden dimensions, or the birth of a structure that spans the entire cosmic horizon. The controllers may be shaping the universe into a particular configuration necessary for the event to occur. Once the stage is set, the next phase would unfold automatically, as predictably as a seed germinating under the right conditions. In this view, we are living in a transitional universe, a chrysalis preparing for metamorphosis. The accelerating expansion is the stretching of cosmic tissue before transformation. The universe is not expanding aimlessly, it is preparing to become something else. This raises profound questions about the role of consciousness. If complexity and intelligence are part of the universe's intended design, then consciousness may not be a byproduct. It may be a catalyst. Perhaps the controllers require consciousness to reach a certain density before the next phase begins. Civilizations across isolated galaxies may be growing like neural clusters, evolving independently until they collectively meet some threshold known only to those who set the conditions. Expansion isolates these clusters so they can develop without interference, but the eventual purpose of that isolation may be unification, not physical unification through travel, but informational unification through a medium we cannot yet detect. Perhaps the universe is waiting for consciousness to mature across countless worlds before initiating the next transformation. And perhaps the controllers are monitoring this maturation, ensuring that no sector destabilizes or corrupts the larger process. If so, humanity is not alone. We are one neuron in a cosmic brain still forming across billions of light years. This interpretation radically redefines the future of intelligence. Instead of expanding physically across the galaxy, civilizations may evolve inward, refining consciousness, information processing, and non-physical modes of existence. Physical travel becomes obsolete when expansion isolates galaxies. But at some point, a transition may occur that allows consciousness to transcend isolation. Expansion sets the stage. Metamorphosis connects the actors. The future may not belong to matter at all, but to something that emerges from matter and ultimately transcends it. But these profound possibilities force us to confront the most terrifying question of all. Are we approaching a cosmic milestone? If expansion is controlled, it may follow a schedule. The current acceleration could represent a countdown, a phase that must last a specific duration before the next transformation occurs. We might have no way of detecting whether this moment approaches. It could occur in 10 trillion years, or it could occur tomorrow. The controllers may have no obligation to warn civilizations like ours. Their priorities operate on scales far beyond our comprehension. For them, the transition may be as routine as the rising of a star. The possibility that we live in a universe on the brink of transformation should terrify us, but also liberate us. It means the universe is not a bleak void destined to fade into darkness. It means that physics is not the prison we once imagined. It means that reality is dynamic, alive, intentional. Whatever the future holds, it is not predetermined. It is designed. And yet, for all these monumental possibilities, one fundamental question remains unanswered. Do the controllers know we exist? Have they taken note of the tiny civilization orbiting a modest star in a minor spiral arm of a Milky Way that is already losing contact with the cosmic web as expansion accelerates? Do they perceive our emergence as significant, irrelevant, or simply expected as part of the universe's natural growth? Or are we invisible to them, too primitive to warrant attention, too ephemeral to impact their long-term objectives? We cannot know. But perhaps the question itself reflects a limited perspective. The controllers may not look for individual species. They may monitor information flows, entropy patterns, complexity gradients. They may observe the universe as a holistic system, not as a collection of civilizations. Our existence might matter not because we are intelligent, but because we contribute to the overall informational structure of the cosmos. In the end, the truth may be this: the accelerating expansion of the universe is not the sign of cosmic emptiness or decay. It is the signature of intention. It is the pulse of an ancient intelligence shaping reality on a scale so vast that the entire observable universe is only one small chamber of its domain. We are not witnessing the death of the cosmos. We are witnessing its design, and the next chapter of that design has yet to unfold. Thank you for watching. If you enjoyed this video, leave a like and share your thoughts in the comments. Send it to someone who you think would enjoy this topic too. And of course, subscribe and turn on the notification bell so you don't miss the next videos. See you next time.